I believe we were talking about that example last time where we were using simple interest. I'm here. Actually, I'm here. You will invest money in 2 years to obtain $23,000 5 years from now. How much should you invest at t equals 2? And we said last time that we would actually have to invest more money at t equals 2 such that it grows to $23,000 in 3 years. Then we would have to invest at t equals 0 such that it would grow to $23,000 at time 3, right? And the reason for that, we said, is because you would have missed the highest interest rate years. So the effective interest rate for simple interest is decreasing, so as time goes on, the decreasing interest rate, effective interest rate, would apply to those years. And so it matters where the 3-year interval is, whether that interval is from here to here or from here to here. And that's where we ended last time. So this is just a little blurb describing that, and I will include that in your scan, okay? And I want to move on today. So let us go to page 9. And I'm here on page 9. It says, suppose we begin at time t0 equals 0. I want $k at time t2. What is the value x that I should invest at time t1 to achieve my goal? So this is basically the same question as you just did. Can you give me an expression in terms of a of t1 and a of t2 that answers that question? So I want to begin at time t equals 0. I want k at time t2. Here's t2. I want k, dollars. What is the value x that I should invest at time t1 and let's call that x at time t1 to achieve my goal? Can you help me with this, since we've already covered it on the previous page? Notice that I'm using simple interest. Still talking about simple interest. So what did you learn from that example that we just did? Talk to me. Yeah. Mm-hmm. Exactly. Exactly. So I'm just going to write a couple of intermediate steps here. This would be k, v of t2, a of t1, meaning bring this back to here and then grow to t1, where v of t2 will give you the present value of k dollars, and then apply a of t1 to bring it to t1. So this is equal to k 1 over a of t2 times a of t1. Notice that v of t is always equal to 1 over a of t. So because I say v of t2, I write 1 over a of t2. Because these are reciprocal functions, right? The discount function is the reciprocal of the accumulation function. And then I'm using a of t. Use a of t equals 1 plus it because I'm dealing with simple interest. That's all. Everybody okay with this? I didn't do anything new. I'm just repeating what I did last time. Okay, moving on. It says present value with regard to the accumulation function a of t of L comma t gives the present value of L dollars t units in the future. Let's draw a timeline so that this makes it clear. This is time 0, this is time t, and I have L dollars at time t. So it's saying to take the present value, apply a factor v of t. So here I'm going to get L v of t, which is equal to L 1 over a of t. So L over a of t. That is equal to the present value. PV stands for present value, and we're going to be using that from now until the end of the semester. Nothing new here either. We talked about this discount function v of t last time. Let's do the example on the next page. We did the top of the page last time. We were talking about compound interest. So I want to go to the middle of this next page right here and do this example. What is the present value of $1,200 to be paid 5 years in the future if money grows according to simple interest at 5% per year? Okay, so this one now we've talked about. Please start at 0 and end at 5, and you want 1,200 at time 5, and the question is, what is the value here? So we know that to go from here to here, you have to apply v of 5. So this would be 1,200 v of 5, which is equal to 1,200 over a of 5. What is a of 5 for simple interest? Yeah, 1,200. 1 plus IT. So this is equal to 1,200 divided by 1 plus 0.05 times 5. I is 0.05 and T is 5. That's all. Let's see, what does this give us? Let's get our calculators out, folks. Yeah? So 1,200 divided by 1.25, $960. So if we were using simple interest, we would need $960 now in order to have $1,200 in 5 years. Let me know if this makes sense to you or not. Next one. What if it were compound interest, not simple interest? Then what would I have? Let me draw another picture. Compound interest, time 5. I want $1,200. So this again would be 1,200 V of 5, which would be 1,200 over A of 5. And since A of 5, so A of t for compound interest is 1 plus I to the t, my answer would be 1,200 divided by 1 plus 0.05 to the 5. Again, I'm using the fact that V of 5 is 1 over A of 5, but the A of 5 is a different function. because now I'm talking about compound interest. So what do I get here? Go do it. $940.23. I agree with you. So notice that you would need less money at time 0 if you were compounding, right? You can start with less and it'll still grow to $1,200. So since the accumulation function for compounding, for compound interest, is 1 plus I to the t, which is greater than 1 plus it, you need, and I should say here for t greater than 1, you need less money now meaning 940.23 in the compound case, in the compound interest case, than for the simple interest case, where you would have needed $960. Because your money grows more quickly in the compound interest case, so you can start with less. Follow me, right? Any questions? Let's go to the next page. Net present value is the next topic. So suppose we need to deposit, suppose we need to deposit $2 at time t2 in order to receive L0, L1, ... Ln at times T0, T1, ... Tn. So let me draw a picture, a timeline. Time T0, I want to receive L0. Every receipt is positive. Every deposit is negative. If you give away money, it's negative. If you receive money, it's positive. Okay? So I want to receive L0, so it's positive. And at T1, I want to receive L1, so it's positive. And this goes on all the way to Tn, and I want to receive Ln, so I write positive Ln at time Tn. And in order to do this, I would need to deposit $2 at time T2. So here's my deposit, time T2, L2. And let's say for here, there is no omit receipt at T2, L2. Omit receipt of anything at T2. So the only thing is that you are putting in L2 at time T2. So this L2 is going to be minus because it's money that you're giving away. All receipts are positive, all deposits are negative. Of course, this is from the perspective of the investor, right? So there's something called the net present value, which gives you the present value here at time, let's say at time T naught. Let's say T naught is 0. So net present value is the present value of all this cash flow. So I'm going to say L naught. It's a receipt, it's positive, and it's happening at T0, so I don't have to discount it. Plus L1, V of 1, because I have to bring this back. I need a different color here. I'm taking this L1 and I'm discounting it to time 0. So apply a V of 1 to it. Minus L2. Why is it minus? Because I'm giving it away. V of 2 plus L3, V of 3, dot, 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 Ln, V of n. So this is equal to summation Lk, V of k, I should say V of tk, V of tk, and let me leave this guy separate, minus L2, V of 2. And if I'm using compound interest, it'll be different than if I'm using simple interest. So let's do it for both. Let's say I'm using compound interest. Then the net present value would be summation Lk V to the Tk. Because we know that you raise to the power in the case of compound interest. And then minus L2 V to the 2 power. Yes?
Technically, wouldn't the summation include the plus L2V?
Technically, what does the summation what?
It would still include L2V too, wouldn't it?
Yes, it would, except I want to emphasize the minus sign.
Okay.
Yeah. So if technically I wouldn't even have to write it. So how about I say k not equal to 2? Would that be better? Yeah. You don't really have to separate it. I'm making a big deal here to show you that one of them is negative and the rest of them are positive, because one of them is a deposit and the rest of them are receipts. Yeah.
How would you write the summation if all the L's were like a mix of positive and negative values, or like receipts and deposits?
So I would just go through my cash flow from time 0 to time n, and each time I put a deposit in, I would make it negative, and each time I have a receipt, I would make it positive.
So you're saying make L itself positive or negative depending on deposit or receipt?
Yeah,
Okay.
that's what I'm saying. So can you give me an expression if this was simple interest? Net present value equals what? I'm just going to change my V function right now, because it's A of t is equal to 1 plus it now, right? So, please summation.
And then L sub k.
Okay. L of k.
And then wouldn't you have to go all the way back to 0 and then go back forward? Because
I'm just bringing it to 0. Doing nothing forward. Net present value means bring the whole cash flow to 0. Finish. Okay? So L of k over 1 plus I T sub k. All of these are positive for k not equal to 2, right? Minus L2 over 1 plus what? Can you finish up this expression? L2 over what? 1 plus I T of 2. I'm just saying it's negative at t equals 2. Finished. So I can go and put, yeah.
Is the compound interest that k is not equal to 2?
Yeah, that's what I said right here. Oh, you want me to put it here? Sure. K not equal to 2. Thank you. So I better say here where V for compound interest, V is equal to 1 over 1 plus I. Right? This way I can go put it in terms of V, in terms of I. So this would be LK, 1 over 1 plus I to the TK. Follow what I mean? You will see how simple this is when I do the next problem. This just looks complicated because there's all these T's and V's and I's and L's running around, but let's go do the next problem, okay? Helga has 2 certificates of deposit available to her. Option A can be purchased today for $1,000. Let me make a timeline. Option A, purchased for $1,000 and is redeemable for $1,250. So she's going to give $1,000 to the bank, right? Minus $1,000 and redeemable for $1,250 at the end of 2 years. 2. She's going to get $1,250 back at the end of 2 years. Option B can be purchased today for $1,000. B. Minus 1,000 again, and is redeemable for $1,300 at the end of 3 years. So 3 years, $1,300. Assume that money grows according to compound interest at an effective annual interest rate 5%. Which option should she choose? So basically, which is better? Yes. Sure, we can go back.
For the compound interest in the sub, is it minus L2 be T2 or is it B?
Yeah, thank you. T2. T2 happens to be 2, but I dare not say just 2, yeah. Thank you. Okay. So here she puts in 1,000 and receives $1,250. Here she puts in 1,000 and receives $1,300. And it's saying use compound interest at 5%. Which option is better? Please use the net present value approach. That's what it's asking for. So let me find the net present value here. Net present value equals what? Minus 1,000. I don't have to discount this at all because it's already at 0. This thing is happening at 0, right? Her deposit of 1,000. So I don't have to do anything there. Plus 1,250 V squared, where V is equal to 1 over 1 plus I, right? So minus 1,000 plus 1250 over 1 plus I is 5%, 0.05 to the 2 power. What do I get? When I do this, what do I get? Yeah.
We need to add T1.
Which is your T1? There's only two, this cash flow occurs at only 2 times, right? At time 0, she's putting in $1,000, and at time 2, which is your T1 in this example, she is receiving $1,250. So there are only 2 cash flows here. This one doesn't have to be discounted because it's happening now. So you don't have to bring it back to time 0 because you're standing at time 0 already. But this one, this is the present value of $1,250 at time 0. Right? $1,250, that's happening at time 2. I need to bring it back like this. That's why I'm saying times V squared. Follow? So what is your answer? What do you get when you do this? 1,000? Yeah, you know what? I wanna write it like this so that I can talk about it in a minute. Give me 1 second. Minus 1,000 plus 133.79, thanks, equals 133.79. Thank you. So the present value of this 1,250 was 1133.79. The net present value is $133.79. Do you follow me? Let's do the same thing for option B. Net present value equals minus 1,000 plus 1,300 v to the 3rd power.
Professor.
Yeah.
Move it down.
Thanks. I have it zoomed in so far that you guys can only see a little piece, so just keep reminding me. Thank you so much. Okay, so let's clean this up. Minus 1,000 plus 1,300 over 1 plus 0.05 to the 3rd power. What do you get now?
1122.99.
Okay, minus 1,000 plus 1122.99. So I get 122.99. So the net present value for A is bigger, and therefore she should choose option A. The only problem with choosing option A is that she doesn't know what the interest rate is going to be prevailing in the market at time 2. So she'll get her money quicker, but then there's no telling what the market conditions will be at time 2. Whereas here it's deposited a little bit longer. That's all. So this is saying that 1133.79 is the present value of 1250. Look at this right here. 1133.79 is the present value of this 1250 at time 2. But she's only putting in $1,000 at time 0. So it's basically equivalent to the bank giving her $133.79 at time 0 to deposit. That's free money for her. That's what net present value is saying, right? The present value of this amount is 1133.79. So realistically, had she put in 1133.79, that would have grown to 1250. But she only put in $1,000. So basically, the bank is giving her $133.79 now to do nothing. That's what it amounts to, for free. Whereas here, this 1,300 has a present value of 1122.99, but she only deposited $1,000 at time 0. So basically, they're giving her $122 to deposit. That it's equivalent to them giving her $122 to deposit at time 0. So of course she should go with the higher net present value option, which is option A. So option A is better. Because the net present value is higher for A. Everybody okay with this? So I need to write the bit about the present value of 1250 is 1133.79. So 1133.79 grows to 1250 at 5%. But Helga only deposits $1,000. So the bank ACD is equivalent to the bank giving Helga 133.79 at t equals 0 to invest at 5%. I'm writing all this down because you're not going to remember what I said in class later. So basically, free money, $133. Another way to do the same problem, yes?
So if you forecast both options at the same time in the future, will you always get more for option A?
Yeah. Next page. The previous problem compared two investments based on their net present value. Another way to compare two investments is to see what corresponding effective interest rate each investment gives you. So it's the same problem. Helga has $1,000 to invest. 2-year CD grows to $1,250. A 3-year CD grows to $1,300. Find the annual effective compound interest rate afforded by each investment. This will allow you to show that per dollar invested, your return with asset A is higher than your return with asset B. Can you go find me the two interest rates right now? You know how to do this, don't you? I want the interest rate, so I want this. Minus 1,000 times 1 plus I squared plus 1250 equals 0. In other words, 1,000 times 1 plus I, and let's call this IA after we're done. 1 plus I squared is equal to 1250. Find me the interest rate. That's what I'm saying. I'm trying to find I for option A. So let's finish solving this, right? 1 plus I squared equals 1.25. Therefore, 1 plus I equals square root of 1.25. Let's find that. 1.25 raised to the 0.5 gives me 1.118. 1.118. Therefore, IA, option A, is equal to 0.118. That's the annual effective rate of interest at Bank A. Let's do the same thing for Bank B. Find IB. Minus 1,000, 1 plus I to the third power, plus 1,300 equals 0. In other words, 1,000 times 1 plus I to the 3 equals 1,300. So I'm doing this, right? I'm taking this 1,000, I'm growing it at 1 plus IB to the third power, and I'm getting 1,300, and my job is to find IB. You get what I'm doing, right? So what is it? 1 plus I cubed equals 1.3. 1 plus I equals 1.3 cube root. And that is what? 1.3 raised to the 0.33333. 1.0914. 1.0914. So IB equals 0.091. So option A is better, just like we said before. Everybody good? Yes or no? Two ways to look at the same problem. One was net present value, the other was to find the effective annual interest rate for each method. Let's go to the next problem. Project A requires an investment of $10,000 at t equals 0. Project A requires an investment, so I'm going to make it negative because I'm giving money away, and an additional investment of $5,000 at t equals 1, time 1 minus 5,000, because again I'm giving money away. It returns 2,000 at t equals 3, positive 2,000, because it's a receipt, and 6,000 at 4, 5, and 6. So time 4, 5, and 6, $6,000. That's project A. Project B requires an investment of 6,000 at t equals 0. Make that negative. And returns 3,500 at t equals 1. Returns, so positive 3,500 at t equals 1. And 5,000 at some unknown time. Let's call that x. X unknown returns $5,000. The net present value of both projects are equal using compound interest. Annual effective interest rate 4%. I equals 0.04. Find the unknown time of the second return in project B. So basically you want to take net present value A and set it equal to net present value B, right? Can we do it right now? Net present value of A equals minus 10,000. No need to discount because you're already sitting at time 0. minus 5,000. Thank you. Minus 5,000 divided by 1.04 to the first power. I'm discounting, so I'm using the discount factor, right? 1 over 1 plus I equals V. Are you with me, guys? Plus 2,000, 1.04 to the third power, divided by 1.04 to the third power, plus 6,000, divided by 1.04 to the fourth power, plus 6,000 over 1.04 to the fifth power, plus 6,000 over 1.04 to the sixth power. And let's find that net present value. That turns out to be 1772.57. Somebody check me, okay?
Why do we divide by 1.04?
Okay, so in each case, I am discounting. So the discount function for compound interest is 1 over A of t, and A of t is 1 plus I to the t. So let me write all this, okay? A of t for compound is 1 plus I to the t, and V of t is equal to 1 over A of t. So in order to find the present value of this $5,000, I have to bring it back and multiply by V of t, where V of t equals 1 over 1 plus I to the t. Get it? And I do that for each one. In the case of the $5,000, I bring it back one place, discount 1 year. In the case of the $2,000, I discount 3 years, like that. So that's where all of these come from. Is it crystal clear? Yeah.
So what happens to when t equals 2?
When well, there's no cash flow at t equals 2. So you don't do anything, you just skip it.
Just skip that.
Yeah. So let's do the net. Does this work out? Did anyone check my numbers? Okay, thank you. Net present value of B. Let's do the same thing. Minus 6,000. No need to discount because I'm already standing at t equals 0. Plus 3,500 over 1.04 to the first power plus $5,000. 1.04 to the what power? X power, exactly right. So we have to solve these and see what we get for X. So let's set them equal. Minus 6,000 plus 3,500 divided by 1.04 plus 5,000 divided by 1.04 to the X power equals 1772.57. That gives me 5,000 over 1.04 to the X equals 4,407.19. I brought these two terms to the right side. Therefore, 1.04 to the X equals 5,000 over 4,407.19. So I get 1.04 to the X power equals 5,000 divided by 4,407.19, 1.1345. 1.1345. Let's take the ln of both sides. X ln 1.04 equals ln of 1.1345, and therefore x equals ln 1.1345 divided by ln 1.04. So ln of 1.1345 divided by ln 1.04. 3.217. 3.217. So x equals 3.217 years. 217 years. Get it? Years. That's my unknown. Everybody good? Next page. So next page, I'll just post this to your scan. It gives you the A of t and the V of t for simple discount and compound discount, as well as simple interest and compound interest. It's really important that you commit these to memory and also put these on your cheat sheet for your first exam, because if you can just look at the accumulation function and the V of t and get that right, you get the whole problem right. Right? So let me go through these. I have a couple minutes. Let me talk about these. Let me talk about simple interest and compound interest first, because we've been using this all day. So in the case of simple interest, we know that if we start at time 0 with $1, this grows at time t to 1 plus I t. 1 times 1 plus I t. So the accumulation function, A of t, equals 1 plus I t for simple interest. And the discount function, V of t, is equal to 1 divided by 1 plus I t. Really important that you start with the accumulation function and then use the fact that the discount function is the reciprocal of the accumulation function. Finished. Let's do it for compound interest similarly. You start at time 0 with 1. This grows to, according to A of t equals 1 plus I to the t, to give you 1 plus I to the t, because you only started with $1. And the V of t function is equal to 1 over A of t. So this would equal 1 over 1 plus I to the t. We used both of those today, right, as we were discounting. Next time I'm going to start with simple discount, which is on page 11. And we'll talk about these two cases right here. And then move on. So now we need to see